Alright folks, here's my doc CC. Alright, so in this particular average speed problem, which I think is a little more challenging, so if you want, I definitely highly recommend that you pause the video, get the scenario in your head before you keep up with me, okay? Alright, so hopefully you did. So here we go. In this particular scenario, you have two airplanes that are leaving the same airport, but they're traveling in opposite direction as stated. So here I have a diagram that kind of resembles that. I have chosen the airplane on the left to leave at 9 a.m. You can switch it up if you want. And I've chosen the airplane on the right to leave at 10 a.m. as stated in the problem. Okay. So it says here the first airplane left the airport at 9 a.m. And 2.5 hours later, the two airplanes are 18.25 miles apart. The second airplane left at 10 a.m. and its average rate was 108 miles per hour slower. So here I've italicized the phrase slower just because it is an important fact here. Alright, and it wants us to find the average speed or rate of the first airplane. So let's set it up. Here I have my chart. As you follow along, hopefully as you practice, you can kind of learn what to do with this chart. Here on the left side, I have the first airplane, and I indicate in the parentheses here that it left at 9 a.m. The second airplane left at 10 a.m., which is an hour later. Okay, so here I'll start with the average speed function again, as usual. I'll indicate the first plane as number 1 using subscript here, and then the second airplane as such. Okay. So here I have I have the same function, just using two different subscripts. So let's go ahead and plug in information we know. So keep up, replay if you need to. On the left side for the first airplane, I don't know how far it has traveled, aka D1. What I do know is that the problem tells me that 2.25 hours later indicates that the time that the airplane 1 has flown for is 2.25 hours. Okay, so that's all I know in the first column. I just know the time. I don't know D, I don't know the average speed, because that's what the question is looking for. So here I'm a little stumped. In order for me to complete solving this problem, I have to know what D1 is. And if I don't know D1, I can't really proceed and finish out finding S average 1. Therefore, that's going to force me to move to the right column and kind of wiggle my way through the problem. I don't know what the average speed for the second plane is because it didn't give it to me directly. I don't know the distance the airplane has traveled. What I do know though is that the time that the second airplane has been in the air is 1.25 hours. Now if you're confused as to where this 1.25 hour came from, that's because the problem tells us that the time of the first airplane is 2.25 hours, but the second airplane left an hour later. So therefore, an hour later would imply that you take 2.25 hours of the first plane and then subtract it by 1. That's because the first airplane left at 9, the second airplane left at 10. So this piece of information, it was not like explicitly given to you. You had to do a little thinking to get here. So hopefully that wasn't too bad. Okay, now you got to focus on the problem though. It asks you to find S average 1. Again, so how do you find S average 1 without knowing D1 and D2 and S average 2? So you have really 3 unknowns here. So this is where the thinking part comes in. So play it slow if you need to. Alright, what I do know though is that I can replace the average speed of the second airplane with this substitution. The problem states that the second airplane is 108 miles per hour slower relative to the first airplane. So that's easy to do. You simply take the speed of the first airplane and subtract 108 because the speed of the second airplane is slower. Slower in this case relative to the first plane would imply that you take the speed of the first plane and subtract, not add. Adding would make it faster. It states that it's slower, so you have to subtract. So if you go with that part, the right side stays the same. Okay. The next piece of information that's going to come up is the essential part. What I do know is that the distance between the two airplanes, as stated in the problem, it says that after 2.25 hours, the two planes are 1,825 miles apart. Therefore, implying that the distance that the first airplane has flown for plus the distance of the second airplane should equal to 18.25 miles. Even though they're moving in the opposite direction, after 2.25 hours, that's how far they're apart. Well, that 1825 represents D1 plus D2. So from here, it kind of gives you a hint what to do in terms of solving for S1. What I can do is, though, I don't know what D1 is, I don't know what D2 is. So I can get rid of these variables simply by using the information in the first column and the second column. So keep up here. In order to isolate for D1 in the first column, you would just simply multiply both sides by 2.25 hours, which is what I've done here. Multiplying the right side by 2.25 hours will cancel out the denominator. Multiplying the left side by 2.25 hours would leave us with 2.25 hours times the average speed of the first airplane, which is equal to D1. We could use the same strategy on the second side. Okay, so here, in order to get D2 by itself, where my cursor is circling, I would have to multiply both sides by 1.25 hour. Therefore, multiplying the right side by 1.25 hours would cancel the denominator out, but then multiplying the left side by 1.25 hours would leave me with the statement in this row here. But you notice here I've used parentheses, so it's important that you use parentheses because now you have to do a little algebra. You have to distribute, okay, the 1.25 to S average 1. You also have to distribute the 1.25 to the negative 108. So if you use your calculator, 1.25 times S average 1 is just itself, and 1.25 times that negative 108 will give you negative 135. Now that represents D2. Now if you're sitting there going, well, what do I do with this information? I mean, what's the point of solving for D1 and D2? Well, you want to solve for D1 because the statement that I'm circling again is essential to solving this problem. You know that D1 plus D2, whatever it is, should equal to 1,825. You just solve for D1 in terms of S1, which is what you're trying to solve for. And this is the hard part for kids who are newer at this, okay? You really have to focus on keeping the variable that you're trying to solve for in your system. I kept S average 1 here. On the right side of the column, I also kept S average 1. So now I can substitute out D1 and D2. So what I've done is I've carried this line down here, and here's where I want to do the substitution. Instead of D1, I can replace or substitute D1 with what I know. D1 is 2.25 times S average of the first plane. So that's what I have here in blue. What the heck is D2? Well, D2, which is on the right side of the screen here, is simply 1.25 S average 1 minus 135. So I replace that, I substitute that with the parentheses here in black. So here what you notice is that you went from two unknowns, which is D1 and D2, and you're kind of just chopping it down to where you have just one unknown, and that unknown should be and must be the variable that you're trying to find. So the question is asking us to find S average of the first plane, which we have here in the statement. So here we have two common terms, 2.25 S average 1 plus 1.25 S average 1 minus 135. So here we can simply combine like term. So this is what it'll look like. 2.25 S average 1 plus 1.25 S average 1 will give us 3.5 S average 1. And don't forget to carry down the negative 135. And here, algebra steps, combine like terms. We're going to move the negative 135 to the right side of the equal sign, which will change sign. So now we're going to end up adding 135 to both sides. If you do that, 1825 plus 135 will give you 1960. And on the left side of the equal sign, we simply carry down 3.5 S average 1. Hopefully by now you know algebra well. So therefore, the isolate for S average 1, we simply divide both sides by 3.5. Okay, so dividing both sides by 3.5 will give us this final outcome. So the average speed of the first plane will be 560 miles per hour. I hope that helps. If you need to watch it again, watch it again. But I think this is like a more challenging problem where you are forced to think a little bit in terms of eliminating unknowns, writing true statements, and then know what to do with those true statements. All right. Good luck. Stay nerdy. Don't be whack.